Hello everyone, my name is Cleon from Final Render Animation Studio, and today we'll be covering optimization for beginners and even more experienced developers. There's at least something in here for each and every one of you. I'm pretty certain of it. This topic was actually selected based on feedback from the Jamaica Game Developers Society and will be a series. We're going to be breaking down optimization into 4 different videos, with this first one touching on project setup and basic optimization for all, importing optimization, layout optimization, basic programming optimization, scene optimization, and we're going to also look at what is garbage collecting and what are draw calls. These are all the topics that we're going to be covering over in this video. First thing I want to do is actually quote Arturo Nero, which is a game evangelist at Unity. He says, optimization is a very important topic for real-time applications such as games, because unlike other types of media, we need to make sure things execute in a given amount of time with certain resources, which in most cases are very, very limited. Which is beautifully said, I must say. So, with that out of the way, let's get into the first one. Yes, and this is not a joke, because oftentimes, we get into projects and, let's say, for instance, we use a game jam as an example. We get around with the ideas that we're going to create, we start to put together the scenes and or assets that we're going to be using for this game, and by the time we finish the game jam, most of us wouldn't actually go back to using this project to build on it further, and that's because we haven't created any sort of structure which makes it easy for us. There are many times that we could actually be inside of a project and you just get very frustrated and you start pulling things in, start importing them, dragging them somewhere, and then when you start searching back for them, you have no idea where they are. And so the first thing that I want to do, let me space the word here, is to actually get us set up and optimized so that we will avoid burnouts and actually reduce the chances of us leaving this project by itself. Can actually help to remove ourselves from the developer's loop, which is where you come up with this great idea, start working on it, you get overwhelmed, then you abandon it, then you get this new idea, start working on it. You get where I'm going with this, right? There are 5 folders that I think almost any project utilizes, and so these are the 5 folders that I think everyone should actually create and use inside their projects. By default, Unity has already created the scenes folder, so I won't count that in any of the 5. And the one that I would actually say for us to create is the animations folder, because, well, this is for the 3D side of things. Animations folder because all the animations can be utilized and reused by the same character. Scripts folder, even if you do visual scripting, this is one that you would still use to organize all your scripts, which is the commanding back end of your game. And environment folder, inside of this you would keep your props, you would keep all the designs you did for your terrain system, all the things that you have, like trees if you use them, city, buildings, you structure these into different folders. And we have the prefabs folder. Do I need to even mention why? These folders, you can create subfolders within them that will allow you to keep things much more organized. Say for instance, in your animations folder here, you can always create a folder for your enemies, your enemy animations, separate from your player animations, or even for instance, as we mentioned, with the scripts of which is arguably one of the things that I really try to keep organized, as this prevents any sort of frustration with me when I start to write a lot of different codes. So typically I would have a player script folder, I would have one for the enemy. If I have different types of enemies, then I would probably break it down to that. I would have a separate one for the UI, so UI scripts. I would have one for splash screens, because splash screens and other startup kind of scripts would go in these. So I could either call it, splash screen or miscellaneous, whichever one. And that's the basic layout there. So inside the prefabs, you can have one for the player, one for like your bosses, because sometimes you might reuse them as well. Yeah, I can't spell bosses, never mind that. And for the environments, as I mentioned, we create a folder for the props, one for like your trees and stuff, one for your terrain. I mean, you don't necessarily have to create one for your terrain. You could probably keep with the environment stuff. So it all comes down to you and what works best for you. But that's my basic tip on those parts. This one is going to be for 3D. I'm going to touch on one for 2D as well. So here, where is it? As well. So characters. So you also would create a characters folder. That's the one that was missing from the first one. Yeah. So you can keep all your characters together. Now inside of my characters folder, I'm going to drag in this character that I actually created. And here it is. So with this character imported now, the first thing that I want to do to optimize it is actually go to the models tab here, and what I want to do is check for mesh compression. And we want to utilize mesh compression wherever we want. So this is a character that I don't necessarily need to, but if it is a very high detailed character and he's probably not going to be showing up as much in the scene, then we can do that. Or if you have like a building where it's very dense, highly is a high poly model, then you would come here, use mesh compression. You can adjust how aggressive you want the mesh compression to be. In my case, I'm just going to put that low. And what I want to also make sure is that I have read write enabled, disabled. And the reason why is that Unity tends to create a copy of the actual mesh twice, and this is stored in the memory footprints. So by not having this enabled, it causes for a little bit more optimization as a result. And if it is a model that you imported and it doesn't have a rig, then you can also disable both the blend shapes and the rig on the model. I have this model, it's rigged as far as I remember, so I wouldn't necessarily do this either way. So the third point that we're actually going to be looking at is basic programming optimization. Now this one is actually a very fun fact, you see, and it's something that I think some developers more on the beginner end would actually do, and it is not remove empty Unity events / functions. So these functions actually contribute to small performance reductions over time across multiple scriptable objects. So let's say, for instance, let me check this one. So this one was from a program that I was actually hosting last year, and I'm checking to see if I have any. No, I don't. But an example of this would be, for instance, like the start function without these functions, without these code segments inside of it. So it's actually an empty function right now. And for some persons it'd be like, so how do we, what if I actually need this for debugging, purposes inside of the editor? I can't just delete this each and every time, that's kind of bugging, no pun intended. And so there's actually a solution. So what you can do Like for instance, when you use the debug.log, so you know that that function is only for like debug.log, you might use that and stuff like that. You don't really want that to export out, and you don't really want to delete it either way. So what we can do here is actually use if unity, let me actually put all caps, if unity underscore editor, and right at the end of the function I can just put end if, and I'll be good there. So now inside of the editor is when this function will actually be running, and it shouldn't actually run once you export the game. So this empty function, if it is empty, you would actually have it to be used inside the editor, and once you're done and you're ready to build it out, this function, this if and end if statement will cause it to not end up in the final build, which makes the game much more optimal for your players. The second one that I want to touch on the reprogramming optimization, this one I didn't even know I needed to optimize. I didn't even know it was possible to optimize it. So this one's gonna be a little bit of a shocker. And so here I have on screen a function, and I want you to take a good look at it. Tell me what's wrong with this. Now you're probably saying nothing, and I would agree with you. There is nothing really wrong going on here, but there's something happening behind the scene that most don't know. So here I have another setup. Can you tell me the difference you notice with them? This one has an extra parameters here set up for it. Now what if I told you that even though it looks more complicated, it's actually doing the same function, and this one is more optimized? Yeah, because what's happening is usually when this isn't done, Unity has to hash the values per calls, and in this case the per calls is the jump string, and which, if it's called every time, then it gets hashed every frame before the execution starts, and this adds up faster than we actually think. So by actually creating the parameter name here, so we could actually call this for instance jump ID instead of parameter ID, and then just put in the jump parameter here, then we know that every single time we press it, instead of Unity hashing this for us and then carry out the execution code of actually triggering the jump, we set it here once when the script just starts, and then we just call that hash every time we need it, which is actually a much more performant way. And you can see how if you have like a scene with a lot of NPCs, this could actually help to reduce and make things much more smoothly, and I can see that very much happening. So after some words from our sponsor, and how much needed time to actually just absorb all of this, I have one last trump card. So if you've made it this far and you actually aren't mind blown, I have one last trump card that I think is gonna be mind blowing.
This segment is sponsored by us, Finer Render Animation Studio. If you are looking for high quality 3D models to use in your animated and game development projects for free, go check out our Sketchfab page, which has plenty of 3D characters, game rigged and ready to download and drag into your projects. Buildings which are ideal for filmmakers doing VFX work, animators in high-end productions, and game developers looking for realistic models. All buildings are completed with 2K and 4K resolution texture maps, and in some cases, 8K resolution texture maps, completed with all the different types such as ambient occlusion, normal, and roughness maps to tweak to your projects for optimal realism. We are constantly adding new models for you to utilize to our Sketchfab page per month. That's sketchfab.com/Cleovelo, or check the link in the description for less generic looking models for your productions today.
So, what exactly is garbage collecting? Now, according to some documentations from Unity, C Sharp uses, manage memory with automated garbage collection, meaning that an automatic method of tracking objects in memory and releasing the memory of any object which is no longer needed. So, for the benefit of this is that you generally don't need to manually keep track of releasing any memory which you don't need anymore, because the garbage collector will automatically do that for you, which makes your work easier and also removes a big source of potential bugs. The downside of the garbage collector is that it takes some time to do its work, and this may happen in moments when you would rather not want to spend time on this. Unity uses the Bohem Demirez Wizier garbage collector. I am very certain that I butchered that word a while ago, which is a stop the world garbage collector, meaning that whenever it needs to perform a garbage collector, it will stop the running program and only resume normal execution once it has finished all its work. On screen, I'm sure you're supposed to be seeing a race right now and its pause, and this can cause delays in the execution of the program at somewhat arbitrary moments, which can take anywhere between less than 1 and several hundred milliseconds. Okay, you can stop showing that video now. You don't have to let everybody know that my computer is really out here being abused. Depending on how much memory the garbage collector needs to process and the platform the program is running on. Now, obviously, for real-time applications like games, this can be quite a big issue and isn't possible to sustain a constant frame rate as required for smooth animation if the program's execution can be arbitrarily suspended by the garbage collector. So, throughout all of this that we've actually been talking about, I mentioned, optimizing these different areas because the garbage collector, when it starts to fill up, that's when it's going to take its break to now empty out all of these things. And by actually doing these small optimization, it causes the memory bank to not fill up to that point as quickly. And even if it does, it will be a lot smoother for it to just dish out all of that within the 1 to 100 milliseconds, because your scene isn't very dense in terms of having a bottleneck that everything needs to pass through for the garbage collector to get rid of. And I'm sure I didn't say any of that in a very structured way, but yeah, I'm sure you get the point. And draw calls has to do with how many things are drawn on the screen. So for instance, can you imagine you're taking a picture of 3 things lined up beside each other? Now, when it's not optimized, those 3 things will be taken, as separate images. Then you go into Photoshop and you stitch them together. There you have it, 1 image. Now, these are 3 different images that you put together. Now, if it was an optimized scene, what would happen is you just actually take a picture of all these 3 objects beside each other instead of actually taking them individually. And as you can imagine, when this happens, you are rendering everything in one sequence instead of multiple sequences, which actually reduces your GPU usage and your CPU processing, if I said that right. So that's what I had to share in terms of basic optimization. So the next topic that I'm going to be focusing on in the next video. Wait, before you go, I actually have the trump card to reveal to you, and this plus the draw calls, because I forgot to mention this while I was recording before. So hi, this is editor Cleon. So the draw calls, how this ties into everything is that we're going to show you when working on the UI how to reduce the amount of draw calls so that way you optimize your visual elements on screen. And the trump card that I have is actually a formula that I learned from um, a, a webinar from another Unity instructor that can let you calculate and know exactly what frame rate your game or software would be running at in Unity. So I'm going to jump into the editor and I'm going to show you how to calculate it and how to check it inside of Unity. Alright, so here we are inside of the Unity editor, and this is a project that I'm actually working on. Now, we use this formula to check for the target frame rate that we want this software to operate in. And if I just bring up my calculator here, I'll show you an example as to how we check this. So you would use 1,000 and divide it by the target frame rate that you want. So in my case, my target frame rate that I want to try and capture this for is 60. So I go divide it by 60 here, and the result from this, which is 16.66, is going to be the time per frame in milliseconds. And how we check this, make sure that this is consistent with our program when we're optimizing, is using the stats column here. Now if I press play, so I can run my scene to see how it checks everything. Once it's loaded up here, you can see over here my CPU main. It's also because I'm recording as well. You'll find that values in milliseconds are higher instead of lower. But as you can see here, we're getting roughly 23, 24, no, about 30 something frames per second, if I'm right. Let me calculate it and check. Yeah, so we're getting about 28 frames per second right now based on the CPU main, which is what we want to read to check that. So yeah, so use that formula. You come here, use the stats bar, and once you get whatever you divide it by, you read the CPU main, which is in milliseconds, and that will let you know you're operating in that frame. Alright, take care. Ciao. So the next topic that I'm going to be focusing on in the next video is going to be graphics optimization, and this one will also have probably UI optimization as well. So I'll kill two birds with one stone. So if this video has been very mind-blowing for you or eye-opening in any sort of way, please drop a like below and subscribe so you can see when the next video is out. And on that note, do take care and have fun making your games.